Hello.
Hello, who's this, Gabriel? Okay, so Gabe's here. All right. So let's. Oh, I'm out of time. Class is starting. All right, Gabe. Welcome to class, and thank you for being on time. We're gonna go through our norms, and we're gonna jump into today's assignment. I'm pretty sure other people will be following in afterwards. So let me take attendance real quick, and then we're gonna do the norms. Well, maybe I should get the norms out the way first. It says I'm presenting, so yes, I know, but move. Okay, there we go. So the five basic norms, right? All right, Gabriel, I'm gonna have you go ahead.
No one has to return to the person. Education and the classroom are sacred. We will never behave in a way to cut ourselves, our school, our family. At a cell economy, Southwest students always know that gentlemen, we take pride in cell economy Southwest.
Thank you, Gabriel. Awesome, awesome job, Miss Richardson. Can you read our five academic norms?
We respect the culture of the classroom.
Hmm? You gotta read all five, dear. She read one of them. Miss Richardson, you there?
I'm sorry. We respect the opinions of others. We respect the culture of the classroom. We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for secondary invitations.
Endeavors. Thank you, Miss Richardson. All right, and I see Lisa's here too. So let me take attendance real fast. All right. Let me make sure this saves to the system. Okay, 1 second, y'all. Okay, somebody just put something in the chat. Give me a moment so I can catch up to you. I didn't see Angel. There was only one. All right, so let me save the. I'm gonna come straight to the chat in a minute, but let me just get this resized so I can see the attendance. Oh, oi. You talking French or something? Or? I think oi is OUI. Well, I don't know. I don't know how you meant that, Lisa. But all right, hi. So we're in third period. This is our robotics class. You guys gotta bear with me. These contacts are brutal on my eyes. I'm used to wearing glasses. All right, so Lisa Brown is here. Lee Carter's not here. Latrell Champagne's not here. Khalil Connor's not here. Roy Mine Davis is not here. Miss Franklin, I don't see her. No, I don't see her in the list. Sinkara Laitu is not here yet. Gabriel's here. Dajay, where is she at? She's not here. Joel's not here. Oh, we having a bad start of the week. Lamar Porter's not here. Christian Puentes is not here. Miss Richardson's here. Melody Terry not here. Jamil Tyler not here. Alexis Valdez not here. And Mr. Wallace is not here. So goes the roll for today, or the roll call, or the roster. Now we did our norms already, so now all we have to do is begin starting our Google Doc. As a reminder, the entire class. Okay, I spoke too soon. There's Sinkyra. The entire class needs to keep their cameras on. This counts for your attendance. If you're in the room and you're not responding, you definitely don't have the camera on. You'll be marked absent. You have to try again tomorrow, because if I have to kick you out the room or remove you from the room as the system allows, you won't be able to get back in there till the next day. So it takes about a day before you come back. It's not that the link is not working, but if you weren't responding or nothing, just try it again tomorrow. I think that's how long it takes before the system allows you to come back. Okay. Okay. So welcome to class, Kyra. All right. So let's get into today's assignment.
Mr. Tyler.
Yes.
Hey.
Oh, my bad.
What did you say?
I was gonna ask, is today only one problem?
I don't think so. It should be two, right?
No, it just looked like one full problem.
Okay. I gotta update that. It's supposed. I got on my notes as two problems, but hold on. You said one full problem. Let me take a look here. So we're in engineering 3. Don't tell me the system didn't save right. I think it did though. Okay, I'm waiting for it to scroll. There we go. Okay, it jumped. Okay, wait. Okay, so it says, actually, Lisa, it's two parts to the problem. And then the asynchronous, let me put that in here for you guys. So the asynchronous didn't save. That's what happened. I gotta contact them about these things. I don't like posting the day in advance because it confuses y'all screens. But everybody start working on bringing the first question into your chat. And like I said, the asynchronous problem is just usually you reworking a problem we already did. So the battery's gonna stay the same. This was supposed to be actually 5.47.
Tyler, can you make your screen a little bigger?
Yeah, I was gonna put it in the chat for you anyway, Sinclair. Give me one moment. So the first question, right? Well, let's start with the question so everybody can get that in their document, and then we're gonna go through the agenda real quick. All right, so I'm gonna put it in the chat so you can see it bigger. I think that's the quickest way to make the resolution work, right? And then next, we can't forget about the second question, because that's what you got to tackle later on today. So I'm gonna put it in EDSB, but I'm also gonna put it in the chat. So it should update in my system in one moment. So let me grab that.
Hey, Mr. Tyler.
Who was that? That's Dajay?
Yeah.
Hello, young lady. How was your weekend? All right, welcome to class. Get started. Only like how you said that. Where your camera at? You look like you ain't got no camera.
I don't got no camera.
You need to have one. You got to get on a laptop real soon, young lady.
No, my laptop gonna be done.
You told me what, Tuesday?
Yeah.
Okay. All right. Well, just try to get as much done like you've been doing. Get these questions typed up. So I put both questions in the chat. I don't know how long Dajay's been here, but they should be there. If you don't, I can give it to you again. I know some people can't copy.
It say a uniform and stuff like that?
Yes.
Okay, yeah, I got it.
It's two questions, right? One's synchronous, one's asynchronous. And I probably should have updated that too. Goodness gracious. So the synchronous problem is the first one. Right? The asynchronous problem is the second one. Right, so you can see that. And now all I'm going to do is, in order to see what I did, you got to refresh your screen too, by the way, because it might not change automatically. But let's start with the first part of today. And then we're going to talk about word of the day, document, everything. I mean, as far as setting it up, we're going to talk about that. Go in the chat. Let's see here. I got Richardson already. I got
me. I want to read.
I was going to say, Dajay, you haven't spoke yet. You just got here. Can you read that? You see where it says "Hello, all future." You got to be in the.
Yeah, my bad. I just put myself back on mute on accident.
Oops. Okay. Can you read it now, though?
Hello, all future electrical engineers. Synchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well.
That's awesome. Okay, so the next part we need to read out loud so everybody understands what is expected of you guys. I'm going to see if I can get Gabriel. I haven't spoken to him in a while. Can you read what's in the chat starting with "Please remember"?
Please remember to get maximum credit. All calculations for steps 2. The final answers to the problem need to be uploaded to EDSB via the same format that we have been using since the start of the quarter. This format is shown in the video. Type Google Doc, convert it to PDF. Stay safe and zen.
All right, thank you, sir. Welcome to class, Melody. Terry, Miss Terry's arrived. Okay. Let me see, Melody. I got Sinkyra listed. Terry just got here. Is there anybody else I'm missing? I don't think so. All right, let me check the list again. Okay, so basically we're going to take these two problems, right? You should have already done it. Hold on. Why you always shout? Like, are you talking about Gabriel? Uh,
Yeah.
I don't know. Gabe has a loud voice. You know, he got a strong voice. That's all it is, I guess. But he's speaking up, so that's the best part. I know it's kind of loud. It's loud in my ear too, Lisa. So, what was I about to say? Lisa threw me off. She said, "Why are you loud, yelling?" I don't know, Lisa. I don't know. All right, so we're gonna take these two problems. I'm just gonna copy real quick because I'm showing you what you got to do. Like, okay, we need to start a new Google document, right? And we're gonna establish once it comes up. There we go. We're gonna go straight to your Gmail account first and foremost, and then next you're gonna come here to Docs. All right, letting it cycle, and you click on blank. All right, so now that I got this going, I need to name my document, right? So this is what I'm telling you. If you're on your cell phone, you can still do this assignment. If you're pretty much on a laptop, it's easier because you can resize and work both screens. All right, so the first part is our document, right? Okay, somebody else is coming in the room. It's going to be due now, and you actually be used to this step at this point. Due now. What else is it? Hello, Joel. Uh,
Yo,
and it's also what we got today is the 5th, I think. Yep, October in 2020. All right, so now we need basically our header. That'll be your name, not my name. Next will be the date, of course, the 5th, again of October. You're like, why am I doing this again? Tyler, you're doing too much. Well, what happens is if I go through your documents and I don't see this, I do take off points because it's one thing to be able to find your document name. It's another thing for your document to have a date inside of it. So you gotta do it twice. The period for today at this moment is 3rd. And you guys are intro to engineering students, robotics students. It's intro, the class is actually intro to engineering with robotics. But we're getting to the robotics part once we can get these assignments turned in. And hopefully y'all start to get a lot more done because Thursday, I think product reports go out. So try your best to get these scores in. What was I about to say? What is the title of this page? Who knows what that is for 10 points? You type it in the, oh, Lisa got it, didn't she? Yep. Yeah. Last period was Courtney, now it's Lisa. Here we go. All right, so everybody see what Lisa put. The title is Plates at Different Potentials. So we're doing, Lisa has an advantage because she's doing lower level physics. But when you get to higher level physics, it starts to become engineering. And that's why you guys are starting to do a lot of electricity. You got to understand the basic about why a robot functions. Okay, so questions. Where are those questions? Well, I copied my questions already. You should have copied yours, right? And you see what I have? I have the document set up the same way. Okay. So I'm gonna give you about 1 minute to catch up to me because I know we got some newcomers to the room, but you should have this much set up. You want 5 minutes, all right? And then I'll bring up a simulation where we actually have to simulate what these plates are doing. Now, you've seen this simulation before, but I don't think you remember it, which is why we're gonna go through it again today. All right, so let me just give you 5 minutes. And you got to have this much typed up because after the 5 minutes, we're going to do what's called a share out. So I'm going to change screen, or should I leave the screen up, you guys? Or I was about to change screen to the classroom and let that up for a while, or y'all need to see the screen. You know what to type?
Mr. Tyler,
Yes, Miss Brown.
is there a word for this class?
It
Determinant
is.
math.
It is. For some reason, that didn't save. I saw that, Lisa. And if we go to it, I think it's electric. Let me go to my lesson plan. Goodness gracious. It usually be inside of the brackets, but some of the problems are not saving. I'm gonna start doing mines on Sunday morning. That's what it is. Early in the morning. Okay, so if memory serves me correct, it's electric. Okay, no, never mind. Here's, I'm not gonna do off memory. I'm gonna pull the exact word for today. I'm glad Lisa asked that one. Why won't it show me my old lesson plan? There it goes. In 9, robotics. Let's take a look here. Okay, so I think it's electric energy potential. I think that's the word. Yeah, yeah, I got it. So electric energy potential is the word, right? And put this here. Come over, and what she's asking for is the classroom term of the day. What is it? Is, and I just told you it is. Did I copy it? Yep, there you go. Now the word of the day is, and we'll come back to it to see who remembers. But
Is it?
go ahead. Who said that?
I said it start with a B. It's like blurting some. I
So
forgot
what it-
blurting something.
you said blurting? Not exactly. It's B. It starts with a B though.
Oh, and it is ghost
Yes,
or
it is,
something.
Sinkai. Great job.
How many points I get?
That was 10 points, dear.
I should get half points because I did just
You said the B something.
yeah because I knew it was that word, but I just didn't know how to pronounce it.
You got to come to townhouse because I'll ask you questions like that. But you have the word now, so there's the opportunity to get 25 points if you have the definition. This part is considered your exit slip. I put it at the top because students keep forgetting that it's at the bottom, and it's like, okay, let me put it here in case they remember by seeing it, and that it's 25 points. This helps out previous assignments, by the way. So you can't just put bolster. You got to put what bolster means, definition. And you got to put what electric potential energy means, definition. All right. So that's what Sinclair was asking. What else we got here? I think Lisa asked that question. I don't know. Somebody asked that question. But what we got to do next is, how much time do y'all have left? Got a minute. Let me slow down and get the simulation ready. We're going to be looking at the potentials again, like far as the capacitor place that we did last time. So I'm gonna leave that up there so you guys know how much you gotta have typed up because we're about to do a share moment and then we're gonna do a simulation and finish up with the solution to the problem. So I think we're gonna do the simulation first. Maybe we should do the simulation last. Like, I'm not gonna lie to you guys. I don't want you to not have all the steps to this. Because I'm trying to squeeze a lot in today. There's two parts to this problem, by the way. So we got a lot to do. But let me get the simulation to you in the chat, and we'll talk about the simulation last. That's what I'm thinking on because I'm looking at my notes. It's a few steps. It's not a lot, but it's not a little. All right, stop this. Try to make sure this is the right simulation for you because my other simulation screen froze. I kid you not, this teaching online, man, is something else. Things freeze, it messes up other things.
When are we supposed to go back to school?
Oh my goodness, Najee.
Well,
I wish it was sooner than later. Because what I was told is probably November. Some schools are already doing once a day. And I know students need the one-on-one time, but this is the right sim. But it just depends on them, I don't know exactly when
well,
though.
I know I ain't going back to school because
You don't even want to come back to school. Dang, all right, that's
nah,
cool.
I ain't say that. I said when we come back. Well, when I come back to school, it's gonna be time for me to go already. So
It's gonna be time for you to go.
yeah.
I don't understand, but all right, all right. All right, so the simulation you need is here. I want to make sure I don't forget this before I start the problem off with you guys. It's not letting me grab it. Where'd it go? But I do wish we was in the building. I'm not gonna lie. See all your lovely faces and see those bulbs turn on and stuff in your head when y'all get problems. That shit, I mean, that stuff was cool. I'm sorry. So let's hear. You got the plates here. Did everybody see the plate? Okay, I think the screen.
Yeah.
So you see this simulation? I want to make sure you know where I'm going. I'm gonna next take the link for this simulation, and it should give you the same startup page. So we'll put this in the chat for you, and I'll also put the link in the recording for today's video, where you can click on the link and play with it some more. But we're not going to jump into it yet because we got steps to do with this math problem, right? So just start that up because it takes a while to load, but be ready to come back to it because you're going to take a print screen. Those of you on phones, I think the iPhone, you got to press one button and another button to take a snapshot. Those of you on Chromebooks, there's an article I gave you, and if you need it, just do a little Google research. There is a way to print screen on the Chromebook. You just type in the Google search, how to print screen on a Chromebook if you don't have the print screen button. All right, so I think I've said enough. Let's get into the meat and potatoes of this problem. All right, so you have your documents set up, right? And I was going to give some time to share out, but then I had to explain some things. So I'm going to come back to the share out and see how much you've got typed up along with me. So now's the time to pay attention and type with me. If you don't understand something, just speak up and say, Tyler, what is that? And I'll try my best to explain it, all right? So the first thing we need to understand is the problem. I think someone already read the problem in the chat, or did they? I don't think they did. The uniform, yeah, we did. I think Lisa did it. I think we did it already. So what you want to understand is you have parallel plates, like the simulation you're supposed to be looking at. And I'm gonna show that very briefly, but we're not gonna do the snapshot. So this is a capacitor lab, and you see in this section, I gotta restart it because it's like the screen is not even right. So there's two plates, and in between the plates, it looks like there's nothing, but there's actually an electric field that's generated. We talked about this last week when we had E fields. Now we're looking at the potential or how much voltage you can get from the particular fields. So I'm trying to give this a moment to load up, but I'm going to come back to it. So let's discuss what you need to solve the problem. You need a definition that goes by, is called the connection between the electric field and the electric potential. So connection, these are notes that go in the center of your page until we start doing the steps to the problem between the electric field, right, and the electric potential, right? All right. Now, what does that mean? Well, we have to, flesh out what the equation is. So in one essence, you have the electric field. This is the equation written out, but I'm gonna write it smaller in math form in a minute. And that's gonna be equal or equivalent to negative, right? And it's change in electric field. Not potential, sorry Google, but field. I hope you guys are getting these notes down. It's gonna be divided by distance. Okay, so far so good. Now let's break that down some more. What are these things measured in, right? So if we come down, electric field is always measured in a volt per meter. So volt per meter. Okay, that's one. Very important because we got centimeters up there and we're gonna have to change that in a little bit. We gotta convert it. It's gonna be equal to minus, and in these parentheses, what is that measured in? Well, that's the volts. And you know what the volts are because that's how you know how much power you have on your battery. All right, this is going to be divided by what? The distance, which is in meters. Okay, so now you know. It's usually a lowercase m when you're talking about meters, but we'll leave that be because I don't want you guys getting confused about it. So now we got to talk about how it looks mathematically. Or in physics, there's an equation or formula. So E, which stands for your electric field, is equivalent to your delta V, and delta V, you got to take it from here, So insert. We're going to insert. We're going to special character. We should be used to this. Okay. So we got that, and now I want to say, hey, no arrows. I want to choose math. This is inside of Google Docs. It's not nothing special I'm doing. I'm going to type delta because that's the actual symbol I would like. Click this, which means Greek letter delta. Believe it or not. That's why I say it's a difference when you're doing math. The Greek letters, they mean things. And what does that mean inside of it? Delta means change in. So you have a final minus initial. If you don't remember slope calculations, you should review it. So it'll be delta V. Divided by, what else do we have? Well, our distance. And you just put lowercase d. All of this is going to be negative because there's a negative sign that starts in the above equation. I had a question. I'm going to put this in the center. These are your notes so we can tackle the problem. And there's one other equation we're going to need because there's two parts to this, right? And one moment, it's about the potential energy, right? And this is what delta E is. So like if you don't have delta V, then you have a way to calculate for it. In this case, we do have it, but then you want to go back and be able to find the electric potential energy. That's the word of the day, right? Or the classroom term of the day, electric potential energy. So here's what it means. Somebody else is coming in the room. So the definition, Ms. Franklin, welcome to class. The definition of electric.
I'm using my phone.
So you're gonna have a hard time doing the work, but you got to do it. So
Hey, what?
you're gonna have a hard time doing the work, but you got to try it. Y'all be on these cell phones. There's only so much you can do on a phone. So let's keep going. So this is known as V that we talked about, electric potential energy. I kind of gave it away, right? But you can still look it up and give a good definition for it in the word of the day and term of the day up top. So let me slow down and do attendance. So we got Richardson's been here. It's Franklin that arrived and Joel. I got Joel marked already. It's Franklin that's not linked. There we are. Okay, got them both. Well, I had Joel already. Okay, so now let's resize the screen so I can see you guys. There we go. Okay, now I can see better. Okay, so let's keep going, right? There's a lot of cameras off. What happened to everybody? Y'all switching screens on me? Is that what y'all gonna say? I see Richardson. All right, so we got to keep going. Electric potential is the amount of work needed to move a unit charge. Very good, Gabe. Now you got to put that in your document up top, dude. Don't forget. Very good. Got about 10 points. That's participation. Okay, so remember I told you about delta V. It goes here because we're going to define it. We may need to use it. So as I was going through the notes, I was noticing that. So delta V is equivalent to what? Well, you got to take delta again because we got to look at the change in potential energy. And Gabe just gave us a definition a moment ago. That was really awesome. So it's called delta PE for electric potential or potential energy in some cases. All right, so, or electric potential energy, I should say, because it is a form of potential energy. And it's divided by Q, which is charge. Okay, so this is like a bit of a review from last week. If you don't remember these equations, here's what they mean. So we know that delta means change. I'll write it out for you first. Change in electric potential is equal to, let's put parentheses around that so you understand what they mean. So that's the first one, delta V. I put it above it. I probably should put it underneath. That's how y'all used to seeing it, right? So we'll come down here, over here, right there. And change in electric potential is equivalent to what? Well, that's equivalent to the change in electric potential energy. Sometimes confusing. There we go. Can't spell energy today? Dude. Okay, so let me scroll down so I can see. All right, I can see better now. So this is the potential energy, and one's just a potential. Don't get them twisted. And this is divided by the charge. That was Q in the bottom. Q is usually in coulombs. If you don't remember that, take a look at some of the previous videos. All right, so that's, I think, enough where I want to stop and take a look. I need to check in with you guys. Nobody's really showing their cameras anymore. How you guys doing? Where you guys at? I only see one person, and that's Richardson. She's got it towards the ceiling. So I gotta start calling on people. If you're not responding, then
I'm right here.
I see you, Richardson. I've been calling your name. We're looking at Franklin, like to Lisa. What happened to your camera? It's black.
Mine's on.
You said what, Tyler?
So y'all
Everybody's on.
your camera's on?
Everybody's on.
Okay, so I'm gonna restart. Y'all keep going. I think it's probably on my end. Let me restart the screens.
Oh, look at my nephew.
Girl, he throwing a fit.
Send Kyrie.
Hey, Mikey, bro. Yeah.
They both said the baby gonna be getting all the girls.
Yeah.
Y'all trip. Oh Lord. All right. So let's keep going. let's try to stay professional. This is still being recorded. So I see everybody's cameras. Now the next thing is what was the next step? So we'll come here, and I was going to tell you what each of these mean, so we can calculate it out. The time is 12:52. We get out of here at 1:20, so I got to hurry up. Okay, so let's go through it, and I'll just tell you what they are afterwards because we don't have a lot of time for all that. But electric potential, so you know, is usually measured in volts, right? That's your voltage. So I ain't got no choice but to explain that. Pick up time, but oh well. Volts is equivalent to, and then we talk about electric potential. Remember, it's a joule per coulomb. Now, potential energy has always been joules. Kinetic energy work, so you guys should be used to joules. This is going to be divided by what is charged. Well, that's a coulomb, right? A coulomb. All right, so that was the note I was just dying to tell you guys about. So now known, we know, and unknown, what don't we know? This can come up. So if we're looking at this correctly, we know our potential, right? Remember I told you about that? Is going to be about 12 volts. Okay. So we come down here, and we're just going to call that negative 12 volts because of this equation. See, there's a negative sign in there. There's a negative there. And this is the potential we were talking about, delta V. So as we go down, we'll say delta V, and I'll take delta V from here. So where we go? They put electric fields, will be electric potential. Okay, let me see here, make sure that's correct. I don't want to try getting the wrong notes at all. Yeah, okay, it's potential over distance, right? Awesome sauce. I got electric field from upstairs. That's probably why I said that. Come on, man, fix yourself. Yes, I meant potential. There you go. So I'm gonna take this delta V here, copy it, and bring it down. You should have found where it is from the insert feature. We'll put that there. Okay. So it's supposed to go there. And it's equal to, well, we said negative 12 volts. That's what the problem gave us. So you guys had to walk through this problem, right? Next one is what? It says if a plate has a separation of 0.75, That's the distance, if you didn't know. So distance, lowercase d usually, is equal to, we said 0.75 centimeters. Now you know we can't use centimeters, we have to use meters. So what we got to do is convert it. Who can tell me what centa is? What power is centa? It's a prefix. That's 10 to the what power? You might know. 0.75. So we got to convert this. Let's see if anybody got it in the chat at all. No, I got a fresh chat. Nobody got it yet. So if you don't know, you just take the number and you're going to multiply it by 10 to some power. And that power.
Lisa said -2.
Oh, she did. Thank you, Dajay. Great job. It's going to be times 10. Thanks, Lisa. And then you put the -2 here, but it's not subtracting 2. You want to write it, but then highlight it and raise it to a power. So I'm going to raise it up. And don't forget, this is just going to be meters now. So I'm going to turn it off after I raised it. Come over one is meters now. So that we can use that. All right. Let's keep going because we don't have too much to do, but we do got to put this in the equation and make it work because we have part A to do. So what else are we given? We're given Q, right? That's our charge. And I'm basically using this equation here. Okay. And I think this one's going to be used a little bit later on. But let's start with what we do know. When you're talking about, Dajay left, oh no. When you're talking about finding E to find delta PE, you got to first think about how charge comes into play. And charge is a little bit later on. So we're going to start with the distance and delta V, and then we're going to come back and we're going to find part B, the delta V, right? Because we were given that, but it's asking in this equation for PE. So pay attention to that. So I'm going to put the charge in because we're going to use it later. And welcome back. Okay, she made it back. Having problems with your phone again?
Yeah.
No, poor baby. All right, so I was just telling the class that Q is the next one we're using. And that's for charge, if you don't remember. And that's the charge. So I'm not going to put -6 there. I'm actually going to reduce this to what it is. So it's -6, but it's really 10 to the -6 power. So we'll do that. Come over a few steps. Then I got to turn it off because I want it to drop down and work. And that's going to be, what did we say? It was in coulombs, right? For a charge. I got that from above. Coulombs moves through a positive plate, negative plate. And that's in a simulation if you have it. Okay, so now we got what we need. What do we need to find, right? That's the unknown section. So that's going to be E for our electric, I want to say field. Let me see here. Yeah, electric field is equivalent to some number we're going to calculate. And remember, I told you earlier that electric fields is measured in volts per meter. Okay. So I'm just going to take this here. Hey, that's what we're looking for in the end. Electric field when we do that. But it's measured in. But what it is, we have to calculate. So that's one part, and this is basically part A, right? So let me come to the beginning of this. And this is our part A. How's time going? We got about, not bad, not bad. It is, can you come back? And okay, hey, you tripping. Let's move y'all over. There we go. A lot better, a lot better. This is part B. I'm sitting there playing with the keyboard, trying to get it right for you guys, and look at the clock. So that is the change in. That's our delta PE there, right? That's the part I said you got to figure out. This part, we got to do some algebra on that. That's why I'm like, we're a little strapped for time. Okay. Now, that's going to be some number measured in. I told you already, PE, delta PE, or change in potential energy, electric potential energy, is simply going to be measured in some number in joules. Okay. All right. Whew. Said a mouthful, right? Let's keep going so we can finish this off. And it's 12:59, so I'm trying to get you guys out of here at least 5 minutes early. But we got a lot of steps, and we still haven't done our simulation. So let's power through it. First equation we're going to take is that one for the electric field, right? This baby right here. And I'm going to take it and put it downstairs so it can be used, and bring it over to the side. And right now, the reason we did all those steps is so you can start plugging numbers in and start getting answers. So, like I said, we're not going to use Q yet, but we are going to use delta V and the converted version of our distance. So I'm going to highlight this, copy that, come down one, and this distance is basically what we get listed here from the problem they gave us. Right? So I'm going to copy that, and that's our distance. But you're not finished. Don't forget you have, and these are pretty much, you keep them in parentheses so it don't get too messy on you. So this change in electric potential or voltage is just -12. Let's take that. That goes here. I already got a negative on the outside, but it doesn't go again. So just put 12, right? Volts. Cool. So the next step is to calculate it, right? But remember, it's negative and there's another negative. So what's going to happen is you end up with a positive. So I want to slow down and show you that step so you didn't get confused. The equation already comes with a negative, but the volts were already negative as given in the problem, okay? All right, so let's keep going because remember the plate is coming from negative, from low to high, so that's why it's negative. All right, let's continue. So we calculate this, and remember these two values of volts and meters become volts per meter. Copy and come down one. And we're gonna take the volts and put it over here because it's gonna become volts per meter. We have above in our notes for, right here if you don't see it. So I'm just cleaning it up for you. See there, I don't want the parenthesis there. There we go, and then it's volts per meter, or V over M, if that helps you. Okay, and don't forget that this negative and this negative, they're gone, because this negative times negative makes a positive value, right? So we can get rid of that and that too. And now we end up with what? Well, it depends on what we calculate. So let's use Symbolab for that because it's easy. And that's going to be what? Okay, so we come here, Symbolab. I should put that in the chat in case you guys forgot what Symbolab is or where to go to get it. Copy. And paste this here for you because we're almost through with this. Well, I put wow? No, I thought I copied Symbolab. Oh, I put www. Copy. Who's coming in the room now? Okay, there's Symbolab, everybody. And let's calculate it out. Let's see who gets the answer first, right? So how do we do this? That's Christian coming. So it is simply, you type it in, click here, enter problem, and it's going to be 12. You can use a fraction if that's easier on you. So we come here, you put the fraction, you click on the fraction symbol, it makes one for you. And it's going to be 12. And I hope you're practicing with me because you guys got to do this tonight with your asynchronous problem. And then what goes in the bottom? It's 0.75 multiplied by 10. To raise something to a power, click here. It's -2. Right? So if I hit enter, it'll cycle and give me an answer. And it looks like it's almost through. What's the final answer? 1600. Huh? So pretty cool stuff. So that means that part of the answer for part A is equal to, the electric field is equal to 1600, and we'll say that's volts per meter. That's one answer. We got one more to go before we get out of here. We got 7 more minutes before we do the simulation. So let me hurry up so we can do the simulation and possibly get you guys on the road. So this volts per meter, not meters. And now we got to do this basically right here is all of part A, by the way, everybody. So don't get confused. This is part A that we did here. Now to do part B and finish this off. So part B. How do we get that done? Well, that's that second equation we was talking about, right? And in order to do it, let's go back to the top and let me open the screen up so you can see it. In order to do it, you needed to first find, like I said, the electric field. And that allows you to go back and figure out what, this potential energy would be. So now that we have that, because that was, and when you're asking why we had to find that first, that's the first question that was asked. It says, what is the magnitude of electric field in the capacitor? We did that part A. Now it's saying, part B, hey, you got this charge, like Gabe explained earlier, and it moves from plate to plate real quickly. And you'll see that in the simulation. I'll share the simulation out with you guys again in a moment. However, what does that mean? It's one of my favorite questions that students always ask. What you mean? So we got to recalculate this with some algebra real quick. We had to solve for, was it delta PE, right? Put the equation here. We're solving for this part. So solve for delta PE, or the change in potential energy, electric potential energy, using algebra. So we notice the equation. We'll bring this over, and we're gonna, do some quick algebra. It's like probably 2 steps to get this correct. We'll move this homework problem out the way, and I'm gonna take this because this is the equation we're working on. Come down one there, and what do? Well, notice that the Q is being divided. I did not, Sinclair. Was you gone?
Yes, I was using the washroom.
Okay. I hope you can catch up. You have to watch the video, dear. I don't know what you missed. Copy this chart.
Okay.
And I'm putting the chart here, guys, because it's being divided, if you see that. And what we want to do is we want to cross out the Q's, or the charges. So I multiplied, but what you do to one side, you got to do to the other, right? So we're going to take this multiplication of Q over here, and I'm just setting it up for you guys, but it's going to be multiplied by Q as well. So this is what changed in the equation, by the way, from above to the below, because we did some straight algebra on this, but before we didn't really do no algebra. We just did conversions and calculated, and we were done. Now we got a few, calculations or conversions to do via algebra. So that's a change from the first step to the next step. Now, what's the very next step? Well, you want to cancel out some things, right? So let's see what happens. And if we do that, we should be very much left with delta PE. So you highlight this part and cross out that, because those Q's, they cancel each other out. You need to cross out this as well. Okay, so new equation. What does that look like? Well, I'm gonna do it in reverse. I'm gonna say, hey, delta PE, because all this is gone, and that's gone, is equal to what you see over here. So I'm gonna take this, come over, put that there, equals, and over here, this is pretty much be rewriting it to make it look better for you. All right. So it seems like we're pretty much getting close to the end. Let's finish it off. All we gotta do is take what we have in our unknown values and solve it all the way out. So let's do that. I'm down, I'm gonna copy it and do one more iteration or one more step. I'm gonna say, what is, delta V? And we know that to be what? Well, we know it's negative 12, right? That's what we did earlier. That's what we noted. So we're gonna take negative 12 and put it inside the equation. New equation we created. So instead of delta V here, you'll have negative 12 volts. Instead of this Q, you'll have the actual charge in coulombs. So it'll be this, and it has to be the converted version, right? Well, I'm talking about the Q, not the converted version for distance. So let's take that. Let me over here sound like Puff Daddy. Take that thing. I copy this. And I'm gonna put this in here for Q. Okay. So now all we gotta do is combine. And if you remember that, if we go up to the top, because we're about almost done with this problem. If you look at what delta PE is, it's in joules. But inside of, basically, when you put these two together, the volts and the coulombs, they combine to make the joules in this situation. And that's usually all they are, if you remember last week's discussion. So we're going to rewrite this so you just have joules. Remember, I told you that's what it's measured in. Coulombs crosses out. And then volts crosses out. And the plans here is when my powers combine. Okay, and then what jumps out of that whole situation when they do that product is joules. Okay, let's clean the equation up, calculate it, and then call it a day, everybody. We still got to talk about the simulation real fast, so let me do this quickly. So I'm just cleaning up the document, show you the final steps, and then I'm going to take this and put it in Simulab. Well, I don't think it's going to do it right. I got to do it for Simulab. So what is that going to be? Well, that's going to be negative 12 multiplied by, and we're going to put this in parentheses, is what, 6.27 multiplied by 10. We got to raise that to the power of negative 6. So come here, raise it, negative 6. And then all I got to do at this point is hit enter, and it should calculate out to what? You set this up and get ready. Looks like it comes to about a negative, wow, right? And yes, you got to put all those numbers because there's the zeros. So we almost out of time. I know my prep period. I get it. So let me finish up, guys, so I can get ready to let y'all go. Our prep period is like, you got to go. So what do we got? We got delta PE, right? Let me blow this up. Highlight this, equal. Come down 1. And delta PE equals what? Well, that's negative 0. I think it's 4 zeros and 7524. And this is going to be in terms of joules. Okay. So, and it's a lot for a small point charge, but it may look like it's not to you. And that is the final answer to part B. Okay. Bold your answers, so I'll know. It's kind of like when we was boxing our answers in school. Now you just bold them. And that's pretty much it. Now for the simulation, you need to take a picture.
Can you go down right quick, Mr. Tyler?
Yeah. There you go. All right, so I want to talk about the simulation, and I want y'all to get the picture of the simulation where I'm putting it at. Make sure you're into the simulation now. And Dajay, can I switch screens for a second, or you need more time?
You can switch screens.
Okay. So if I click here, it says still initializing. That's so sad. All right, so, okay, here it comes. Did everybody initialize their simulations already or no? Because I wanted to show you these plates we were talking about, the whole problem.
The batteries.
Yours is still loading, Lisa, or no?
I was asking, was it the battery simulation?
It says capacitor lab. Did you get that?
Yeah.
Okay. We're going to the one where you have the plates. A Simulab, and this will be the actual simulation. There it goes. Okay, I was like, come on, I'm trying to let the kids go.
Wait, hold on, Mr. Tyler. I'm trying to get to mine on here real quick. Okay. Well, you could go. You could go.
Okay, but you got till 8 to do this, so don't worry. Just try it on your own. But you have to take a snapshot, and I think Lisa said it, the introduction, with the battery and the plate. Imagine this is your 12 volts, right? And then over here you have the plates, and they separate. So store energy, click on that, plate, capacitance, okay? Then the electric fields. That's the only picture you need for today. Tomorrow we're going to be going further into dielectric and multiple capacitors. So the print screen, you either press the print screen button or you do it the way you can on your phone, and you insert the document by copying and pasting it right into your Google Doc that you was working on. So is it the right Google Doc? Yeah, this is the right one. So I can paste that right here. And that's a part of your score. So take some time, play with it. Make sure you crop your image like I got to do real quick. Click on the image and cut out the nonsense. You don't need all that there, right? So cut that out. I'm going to cut that out. And again, these features are tough to do on a phone. So that's why I'm like, y'all need to get on the laptop, bro. It's like, y'all keep trying. I know you like to use your phone, but it'll hurt your score in the end.
Wait, now, Mr. Tyler.
Yeah.
Can you do it over for me?
What do you mean?
What you just did?
Oh, yeah, sure. So do you have print screen on your keyboard?
Keyboard?
Okay, do you got a keyboard?
No.
What do you have?
A phone.
Oh, you on a phone. So you got to do a screenshot, Dajay.
Yeah, but I'm telling you, like,
The setup.
yeah.
So again, it's you want to make sure capacitance on, plates, plate charge, stored energy. Those are the meters. And then
Yeah.
don't forget in the view, plate charges and electric field lines.
Okay.
Okay. All right. So I think that is about it. I was gonna say share out, but we've been
And
sit.
then
Go ahead.
what to do?
You gotta take a screenshot of that and probably put it in Edsby so I can see it. Because you said you had
But
trouble.
how you get them? How you get that? Like, most of not.
The electric field lines.
Yeah,
You gotta click on it, Dajay. See up here, it says electric field lines.
I did.
Okay. You want to share your screen? Maybe I can take a look at it. I don't know. Maybe are you in introduction or are you in a different sim?
Oh wait, no, man, I was at the wrong thing.
Okay, there you go. Yeah, we're gonna talk about the other things tomorrow. All right. So does anybody have any burning questions? Remember, the videos will be ready for this class by 4 today. But do you have any questions for me? Now I do know. Here's a note. When they're in the library, the videos sometimes when you click on the YouTube link, depending upon if you're on a CPS laptop, some of them are restricted. So you have to, if you are restricted and you have no way of using your personal Gmail account, you can still download the movie file and make it work for whatever problem you're working on. All right. So with that said, it is 1:16. I'll be on here for 2 more minutes before I get ready for next period. But do you have any questions for me? Okay, Gabriel shaking his head. Y'all gotta speak up. This is me checking to see if y'all still in class. Dajay, Richardson, Terry, Lisa shook her head. Okay. So those that
I'm okay.
Yeah, I'm in class.
yeah, okay, who said that? Richardson or Dajay?
Roger.
Okay. All right, Dajay. Well, you have no questions. I'll see you tomorrow, same time. Try to turn in everything by 8 p.m., you guys.
Okay.
Melody, are you there? Screen's frozen. Christian.
Have a good day.
You too, Lisa. Bye-bye. Okay.
Thank you.
All right. Melody, you there? Couldn't hear you. Okay, Christian.
All right, I'm on, Mr. Tyler. My bad, I
Oh,
came to class so late.
okay.
You know,
All right.
I'm out.
I'll see you. Try to be on time tomorrow. See you tomorrow.
All right, I got you.
8 p.m.,
I'm here too.
everybody. All right, Franklin. 8 p.m., turn it in.
Okay.
All right. Terry, are you there? I can barely hear you, dear. Okay. Well, try to get your microphone working better by next period. You're going to need it. But the class is about to start in about 3 minutes.
Mr. Tyler.
Yes. Now I can hear you.
Yeah.
Okay. I couldn't hear you before. Your mic was on and didn't say anything. All right. Okay. She left.